Today we continue the next point, operational amplifier. In that article, we discuss about the schematic symbol of operational amplifier, pin connections of IC 741, block diagram of operational amplifier parameter. All these points we discuss one by one. The schematic symbol of operational amplifier shown here. Here, the triangular form of IC, which signifies operational amplifier integrated circuit for IC 741. We know operational amplifier is a direct coupled amplifier with high gain, and it has two inputs V1 and V2 and one output V0. In that, V1 is inverting input and it is shown negative since input voltage V1 and V0 are out of phase, while another input V2 is shown as indicate positive and it is non-inverting since V2 and V0 are in phase. Now, what are its pin connections of the operational amplifier? That is shown here. We know IC 741 used as an operational amplifier. It has 8 pin connections, but out of 8, only 7 pins are used. Why it is named as 741? That we firstly note here. Since operational amplifier has 7 functional pins like 2, 3, 4, 5, 6 and 7 except 8. These are 7 functional keys. In that 4 pins are capable of taking the input like 2, 3, 4 and 7, and 1 pin is a output pin, and therefore operational amplifier named as IC 741. Now, what are these pin 1 and 5? Pin 1 and 5 that is shown here is offset null. These are at the input stage that are used for the purpose of we can add external circuit in between 1 and 5 to balance the offset voltage. It means the offset null, to balance the offset null, the adjustment is usually done by connecting the potentiometer between the terminal 1 and 5 so as to adjust the out voltage to 0 when input is 0. And the pin connection start from the left side of this panel, 1, 2, 3, 4, continue on the other side, 5, 6, 7, 8. Such a operational amplifier, its symbol and pin connections we use for the next explanation. Here we explain block diagram of operational amplifier. Block diagram is shown here. It shows 5 blocks: differential amplifier 1, differential amplifier 2, emitter follower, DC level shifter and output amplifier. And V1 and V2 are inverting and non-inverting inputs. These 5 blocks and the 3 stages we explain here. The first stage include the differential amplifier 1. It is a double-ended input and double-ended output. V1 is inverting, V2 is non-inverting. In the first stage is taken as a input stage. In that input stage, the first block, which gives input resistance, is very high. Input resistance very high means it has low impedance so as to reduce the loading. Here, the unwanted signals like noise or thermal vibrations are reaching at both the inputs of the differential amplifier equally. Such as signals called as common mode signals. That common mode signals totally eliminated by the first stage, since for that differential amplifier the common mode rejection ratio is very high. If common mode rejection ratio is very high, then what happens? It totally eliminate the noise. Hence, in the first stage, for that amplifier, differential amplifier, the common mode rejection ratio is very high so as it eliminate the common mode signals and it amplifies input signal. In the second stage, here 3 blocks are shown. First, in the second stage, the second block is differential amplifier 2, third emitter follower, and fourth one is DC level shifter. In that, the differential amplifier 2 is a double-ended input and single-ended output. Such a differential amplifier has high gain and also it has high common mode rejection ratio. So, differential amplifier 2 amplifies the difference between the two mode signals. Third block is the emitter follower. That emitter follower has high input impedance and low output impedance. Therefore, that second stage is useful as a buffer stage which avoid overloading. And the third block in the second stage is the DC level shifter. Now, what is the main function of the DC level shifter? Since in that block diagram, all blocks are directly coupled, and if they are directly coupled, then what happens? DC level voltage continuously goes on increasing. Hence, we need such a continuous increasing voltage brought down to zero, and that is possible by DC level shifter. Hence, what is the main function of DC level shifter? It brings the DC level voltage to zero. The third stage, known as a output stage. It is also known as push-pull power amplifier. Since the output impedance for the third stage is low, so as it provides the sufficient current to the load without any distortion, and therefore it gives the large output voltage. Hence, if I conclude here, the operational amplifier is generally operated in a single-ended input and single-ended output. Now we explain operational amplifier parameters. The first parameter is input offset current. Now what is input offset current? For a given op amp, there are two input V1, V2. In that V1 is inverting, V2 is non-inverting, and one output V0. In that, the difference between the current flowing through the inverting and non-inverting terminals of an operational amplifier must be equal to I0 is equal to I1 minus I2. That difference gives offset current I0, and it is of the order of 20 nanoampere. Another parameter is input bias current. The input bias current is the average of two currents, I1 and I2, flowing into inverting and non-inverting terminals of an operational amplifier. Therefore, its average value we have to take I1 plus I2 divided by 2. Such an average current flowing across the two inputs is known as input bias current, and it is I1 plus I2 divided by 2, and it is of the order of 80 nanoampere. The next parameter is input offset voltage. What is input offset voltage? If input voltage is given to the terminal 2 millivolt, which is applied to the input terminal to make the output becomes to be 0. Next parameter is input impedance, denote Z in. It is the ratio of input voltage to input current and is measured in mega ohm. Next is output impedance. It is measured between output terminal and ground. It is always of the order of 50 ohm to 200 ohm. Means output impedance is very low. Slew rate is the next parameter. It is the rate of change of output voltage with time, and it is measured in volt per microsecond. Such a slew rate is depends on high frequency response of amplifier stages within operational amplifier. Ratio is dV0 by dt. Next parameter is open loop gain. It is the gain of operational amplifier without negative feedback. That is the ratio of output voltage to the input voltage without external component. Now, what is the value for ideal operational amplifier? It is always infinite, and for IC741 it is 1 lakh. Next parameter is closed loop gain. It is the voltage gain of operational amplifier with external feedback. It uses the negative feedback, therefore the gain we get with negative feedback. Now, what is the main purpose of the negative feedback that is used in the closed loop gain? Negative feedback gain, due to negative feedback, the gain is stabilized and the distortion to be reduces. For IC741, it is 1000, and next parameter, that is bandwidth, that we determine from frequency response curve. We know the operational amplifier which amplify both AC and DC signal. Therefore, we explain this term by using the frequency response curve. It is the variation of voltage gain of the operational amplifier with frequency of the input signal. The curve shows the frequency corresponding to 0.707 multiplied by the maximum gain, and its corresponding frequency is F1. That F1 is known as cutoff frequency, or also known as unit gain frequency. Up to F1, all frequencies gets amplified by this operational amplifier, and therefore the bandwidth from 0 to F1 is called as F1 Hertz. F1 is unit gain frequency at which the maximum gain multiplied by 0.707 gives F1, that is the cutoff frequency or unit gain frequency. Up to that frequency, all frequencies gets amplified. Therefore, the bandwidth is 0 to F1. F1 minus 0, that is we call F1 Hertz, is the bandwidth of the operational amplifier. For IC741, F unity, that is always 1 megahertz. Now, these are the various operational amplifier parameters. All that terms you must know as we explain the next term. We continue the next article in the next lecture. Thank you.